Hello Math 2 students. In this video I'm going to be going through part of your classwork for week 1.6 on Wednesday, which is the 23rd of September 2020. I'm going to be doing part of these problems. I expect you to finish this out to get credit for this classwork. So it's a lot of pages, but it's also figures and things like that. So it won't take you that long to do the problems. It's just it covers a lot of pages. And then tomorrow you'll just be reviewing for your quiz on Friday, and then that's the end of the 6 weeks. So, all right, so in this first section we've got 6 problems, and we're asked to just classify the triangles by angles and sides. And this is a review of what we did a couple weeks ago. So we're going to be classifying them by their angles right here in the first section, and we're just going to put a check or an X on the right box, and then by sides, scalene, isosceles, equilateral. And then it says name the triangle. I honestly don't care if you write the name down here because you've already identified them with the boxes up here. So our first triangle has 3 acute angles, so of course that would be an acute triangle. And then it has 2 sides that are congruent to each other, and one side that is not, so it is isosceles. So that's all you need to do on these. All right, let's look at this next one over here to the right. By angles, it has 1 right angle, so that would make it a right triangle. And then it also has all 3 sides are different lengths, so that would be scalene. So that's all you need to do there is just put X's on the boxes that apply to it. Okay, the next one, it has 1 obtuse angle right here, so it would be obtuse if it just has 1, and then the sides are all this different lengths, so that makes it a scalene triangle. And then over here it has all angles, all the angles are 60 degrees, so that makes it an equilateral triangle. So we'll go ahead and do that down here because all the sides are the same length, all the angles are the same measure. And it also makes it an equiangular. It's also an acute because all the angles are less than 90 degrees, but it's equiangular, and we definitely want to make sure that we put an X on that box. I want you to finish these out. I want you to do these 2, and then we're going to do this part together. So let's go with the definitions and then pick the right word. I like to go from the right to the left. 3 sides congruent. That would be an equilateral triangle. So that line goes from there to there. Okay. 3 acute angles. That would be an acute triangle. Whoa. No 2 sides are congruent. That would be scalene. At least 2 sides are congruent. That would be isosceles. 3 congruent angles. Equiangular. 1 right angle is a right triangle. And then 1 obtuse angle would be an obtuse triangle. All right, moving on. Next section wants us to solve for X. Now, these look like, the ones on the top are pretty easy because it's just got an X and then it's got your two angles there, the other 2 angles there. So what we know is that 47 plus 62 plus X equals 180. So then we just add up the 47 and 62 and subtract that from 180, and we would get X, and I'm not going to go through all that. I'm just going to tell you X is 71. I'll try to get pink. I like this pink color. 94 plus 23 plus X is 180. And we would get X is 63. Okay, I want you to try number 3 by yourself, and then we'll look at these down here. Okay, so this one is an exterior angle, and the exterior angle right here would be this plus this. So X equals 31 plus 33. X equals 64. Same thing here. This exterior angle equals this plus this. So X plus 3 plus 41 equals 110. X plus 44 equals 110. So X would equal 66. I want you to try this one right here by yourself. It's an exterior angle. I'll just kind of talk you through that part. This equals this plus this. So you try that one. So the next section is congruent triangles, and I want to use some colors here to try to identify what's congruent. So if we look at the angles, which is what I'm going to look at right here, because we have CBA is congruent to, and then we need to name this other triangle in the correct order. We need to put the points in correct order. So C is congruent to X because we've got the two arcs here and the two arcs here. So that's what we want to look for. So my first point here is going to be X. Okay, and then I'm going to get a different color. CBA, so they named the B next. B is congruent to Z because they're both right angles. So this next letter is going to be Z. And then let's do maybe green. A is congruent to Y because they both have the one arc. So that's how you want to do that when you name these. You have to name the second triangle in the right order. Okay, let's look at number 2 together. Make that a little bit bigger. Okay, so CBA. So the first thing they named is the C. So let's do C is congruent over here to E because they both have the two arcs. Okay, so E is my first letter here. And then B is congruent to F. They both have three arcs. So F is the second letter. That one's congruent to that one. And then let's do blue. A, well, A is the same angle in both triangles. So A is going to match with A. All right, let's look at number 3. We'll do all these. Let's see. CBA. So let's start with C. C is congruent to M. And then B is the next one, and B is the same angle in both triangles, so B goes there. And then A is also the same angle in both triangles. So MBA and CBA are congruent to each other. Okay, so let's see. Draw triangles XYZ and DEF. Label the corresponding parts if they are congruent to each other. So we'll grab our triangle tool here. Oops. Oh, I've got it on white. I wonder. Okay. So let's do a red one and a blue one. That was not a good matching triangle. Let's try to make it a little bit closer. Okay. So we have XYZ. Let's do X. I do that every time. X, Y, Z, and DEF. D, E, because they're named like in the same order, and we can't assume that any of the angles are congruent to each other. So what we want to do is we want to say, okay, X and D are congruent to each other. Y and E, and then F and Z are congruent. And so we also have corresponding sides that are congruent to each other, that one and that one. That one and that one, because we can't assume that they're the same length either. So there are our sides and our angles that are congruent to each other. So angle E matches up with angle Y. Angle EFD, which is EFD, is angle F, matches up with YZX. YZX. We could have named that XZY. It wouldn't have mattered. It's the same angle. Side EF, which is right here. Need a different color. Let's do pink. Side EF, right there, corresponds to side ZY. Okay, and then I want you to try 7, 8, and 9 on your own. Okay, so what we're going to do here is decide, remember in the notes from today, it was like these different postulates. This is side, side, side. This is side, angle, side. Excuse me, side, angle, side, angle, side, angle, 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 side. So we have to look at what we've been given. This is side, angle, side, side, angle, side. So we would just need to mark that postulate, and that's all they're asking for. Okay, so this one, all three sides are marked. We don't have any angles that are marked, so it's got to be side, side, side. Number 3 in this section, we have angle, side angle. And it's the side that's in between the angles. So we have this one right here. And then number 4, we have angle, angle, side in that order. So that would be AAS. And that's all there is to that. So we did all of those. What do we know about isosceles triangles? Well, we know that in isosceles triangles, if these two sides are congruent, these two angles are also congruent, so we can solve for x. So the way we would do that on this one is we would set these up equal to each other. 2x minus 10 equals 72. So 2x would equal 82. Divide by 2 on both sides. X equals 41. All right, we're going to do another one together, and then I want you to try the last one by yourself. So again, if these two angles are congruent to each other, then these two sides are also congruent to each other. So 4x minus 2 equals 6x minus 14. I'm going to subtract 4x here, and I'm going to add 14 over here. So then that's gone, that's gone. This is going to be 12 equals 2x, divide by 2. X equals 6. All right, I want you to try that last one in that section. Okay, we're getting there. Okay, this is our last page, special segments and triangles. We did this a couple weeks ago. We did, medians, altitudes, perpendicular bisectors, angle bisectors, and I'm going to use my text box for the definitions, and I'll do all these with you. So I'm going to use my text box and my microphone. So what is a median? A median is a segment that connects a vertex of a triangle to the midpoint of the opposite side. Okay, so now I just need to make this thing fit. I'm going to make this smaller. There we go. I need to make this a little bit smaller print. Let's go with 12. Let's go with 10 or 11. That might work. Actually, that's still too big. Let's try 10. There we go. Okay, that works. And then I'm going to just try to move it a little bit. It's just going to have lines going through it, but that's okay. A median, this is a median right here. Assume that BD is a median of ABC, solve for x. So what that means is that either side are congruent to each other. So 2x minus 7 equals x plus 13. So subtract x over here and add 7 here. X equals, because 2x minus x is x equals 20. Okay, what is an altitude? Let's use our text box again and our microphone. A segment that has one endpoint at a vertex of a triangle and the other endpoint on the line containing the opposite side so that it is perpendicular to that line. All right, that fits okay. It's a little bit big, but that's all right. So assume that BD is an altitude of ABC, solve for x. All right, so 7x minus 15, this is a right angle right here. So 7x minus 15 would have to equal 90 degrees. 7x equals, that's going to be 105, I believe. Yep, and then we divide by 7. X equals, that's 15. I should probably be putting a box around these. All right, next one, angle bisector. Let's define that. Let's see if I can go down to 9. See if that makes it any better. All right, microphone. A segment that bisects an angle of the triangle and has one endpoint at the vertex of that angle and the other endpoint on the side opposite that vertex. Okay. That fit over here. Good enough. Okay, angle bisector means that it cuts this angle B in half. So if it's cutting this angle in half, that means this is congruent to this. So 5x minus 2 is congruent to 73. 5x equals 75. Divide by 5. X equals 75 divided by 5 is 15. All right, we're going to define perpendicular bisector with our text box and our microphone. A segment or line that passes through the midpoint of a side and is perpendicular to that side. All right, there we go. ED is a perpendicular bisector of ABC, which means this is a right angle. So we can find x by setting 4x plus 6 equal to 90. 4x equals 84. Divide by 4. X equals 21. Okay, so the bottom part, I want you to do this part because we did median, altitude, angle bisector, and perpendicular bisector. We did not do midpoint, but I think you can figure that out. So I want you to do that part, and that is matching. So you're just going to draw a line from the word to its definition, and that's it. So we've got through that in 16 minutes, and you have like 4 or 5, maybe 6 problems to do by yourself. So get those done, and I think maybe during tomorrow's live lesson we will go through those, and I'll go through those with you to finish this out, and then you'll have some time to review for your quiz.